Hey guys, hope you're all doing good. In this video, we will be showing you how to create the planetary gear systems using Solidworks. So click on File, New, and then directly go to Assembly. Click OK. Now we are not going to be importing any new parts, so let's just close this. And we are going to get started by importing a ring gear. So let's click on Design Library. And we need to first make sure that we are having the right standard. So go to Toolbox again and go to the ANSI inch specification and then click on Power Transmission, and we are going to go inside Gears, and we are going to be selecting the internal spur gear because that's what a ring gear is. So click and drag to actually import the ring gear. You can see that by default a particular gear has been created. Now the reason why we are being asked for a diameter pitch is because we are using an inch standard. Alright, I hope that makes sense, right? So if you have a module in mind, then what you can do is you can just take the reciprocal of it. In other words, diameter pitch is nothing but 1 divided by module, and you can use that value with an inch specification. Now we are going to be setting up the diameter pitch to 1. And for the number of teeth, I'm going to be setting it to 32. Now the pressure angle, we are going to be using 20 degrees. And for the face width, let's put a value of 2 inch. And finally, for outside diameter, we already know that the pitch circle diameter is 32, right? So the outside diameter should be more than 32 for sure. So let's put a value of 38 here. Right now you can see that as we're typing these values, the gear changes, right? So let's just click on OK. Now you can actually import this particular component. Now we need only one copy of the ring gear, so we can just hit escape so that we don't insert a duplicate ring gear. The next component that we're going to create is the sun gear. So the sun gear, as you know, is actually just a spur gear. So let's click on Design Library, click on Spur Gear, and then just drag and drop it. So let's change the number of teeth to 12, and pressure angle is going to be set to 20. Face width, let's go with 2 inch, the same as the rain gear. And for the nominal shaft diameter, we are going to use a value of 8 inches. Now this is nothing but the internal diameter of the spur gear, right? So with that, our sun gear is done, and we just need one copy of it, right? So let's just hit escape so that we don't insert a duplicate one. So now let's get started with the planetary gears. So let's go to the Design Library and go back to the spur gear. So let's click on the spur gear and drag and drop it. So let's change the number of teeth to 10. Pressure angle is going to be 20 degrees. Face width 2 inch, and the nominal shaft diameter is going to be 5 inches. And then let's click OK. We don't need another copy of the planetary gear, so we are just going to hit escape. So now say that you have accidentally typed the values incorrectly. So let's just click on any particular gear and click on Edit Toolbox Properties, and here you can go back and edit, for example, the number of teeth, the pressure angle, or the diameter pitch. So let's go back to 10 because that's what we need in this case, and then let's just click OK. Now in order for us to position all the gears correctly, we are going to be creating some sketches which can be used to align our gears. So let's click on the right plane of the assembly and then click on Sketch. Hit Ctrl+8 to see the plane in the normal direction. Now we are going to be drawing 3 circles, right? And these 3 circles are going to be coinciding with the pitch circle. Now we know the pitch circle diameters of all the components we just now created, so we should be able to provide the exact dimensions. So click on the circle tool and then select the center and drag it out. Now let's click on the circle tool again, and this time we are going to be selecting the origin and drag it out. This is where the sun gear is going to be positioned. Let's create another circle for the planetary gear. So just click somewhere here and then drag it out. We can fine tune the positions later. So now let's assign the dimensions. So for the ring gear, we are going to be having a diameter of 32 inch. So use the smart dimensions, click on the circle and set the diameter to be 32 inches. Now our document is using a MKS system. So what you can do is you can directly type in IN right? IN stands for inches. So after 32, type in IN, and that's going to set the diameter to 32 inches, and Solidworks is going to do the conversion internally. So now let's set the size for the circle that represents our sun gear. Now the pitch circle diameter for the sun gear is going to be 12 inches. So you can type in 12 and then IN for setting the diameter to 12 inches. Finally, for the planetary gear, we are going to set in a diameter of 10 inches. So type in 10 and then IN and click OK. So you can see that two of our sketches are actually constrained, and for the planetary gear, the sketch is not constrained. Now, as I mentioned before, in order for efficient power transmissions, the modules need to be exactly the same, right? And also the pitch circles should be tangent to each other, right? So what we are going to do is we are going to select the center circle and the circle for the planetary gear and click on tangent. The sketch is still not completely constrained, so let us select the center of our planetary circle and the sun circle and then make horizontal, right? So this is going to constrain all the sketches. When you do this, you can see that a tangent constraint is automatically applied to our planetary and the ring circle, right? That's because we have given the dimensions consistently. So let's exit the sketch. So now we can move on with the assembly. As we have mentioned before, the first part that gets imported is going to be fixed, right? Which in this case is our ring gear. So we need to make sure that we select our ring gear and then click on float. So this way we can actually move our ring gear around. Now what we are going to do is we are going to select the outer circle for the ring gear and the sketch that we created and click on concentric. That's going to align both of them. We are going to apply the same concept for our sun gear first, right? So let's click on the sketch first and then the edge of the planetary gear and click on make concentric. And lastly, we do the same thing for our planetary gear. So make sure that you're actually pressing the control button while selecting both the two edges before you make them concentric. So now you can see that we have aligned them correctly, but that's only in the front view. We still need to push back our gears so that they are all in the right plane. So what we're going to do is we're going to select the top face of the ring gear and click on the assembly's right plane and then click on coincident. And we are going to do the same thing for the other gears, right? So make sure you select the right plane, click on coincident, and finally you do the same thing for the planetary gear. Click on the face, click on right plane, and then click on coincident. So what I can do now is I can just hide the sketch because I no longer need it. Now remember, you're just hiding it. For some reason, say that you want it back, you can click on the sketch again and then click on show. Now we are going to hide it because we really don't need it. Now if you have done the assembly correctly and then if you have set up the mates correctly, you should be able to rotate all these components as I'm doing right now, right? We have constrained it in such a way that there is no translation, it can only rotate. So for example, I can rotate the planetary gear, I can if I select the sun gear, I can rotate that, and so does the ring gear. Now let's take a look at the geometry from the front plane. And what we're going to do is we're just going to move it by visual inspection, and so in such a way that they don't intersect. Similarly, let's rotate the sun gear so that all the three gears are not intersecting at all. The next step is to actually assign gear mates. By assigning gear mates, we are telling Solidworks that hey, these two particular gears are connected, so if I'm applying energy in one of them, that energy or power is going to be transmitted. So to do this, go to assembly, click on mates, and then go to mechanical mates. And when you do this, you need to be selecting the faces that we want to mate. So let's first select the internal face of the sun gear and the planetary gear. So to do this, select this particular face. A small pop-up with the text teeth/diameter shows up, which means you can provide one of them, right? So in our case, we know the number of teeth, right? So what we are going to do is we are going to provide that as the input. So click here and type in 12 teeth. And for the planetary gear, type in 10. And then we are just going to hit OK. Now we have established one mate between the planetary and the sun gear. So we're going to do the same thing between the planetary gear and the ring. So let's select these two faces, and let's make sure that we select the gear mate and type in 10 for planetary, and for ring gear type in a value of 32. Once you do this, click OK. So now we have established all of our mates. So if you put the model in the front view, and if you just click on any of the gears, and if you try to move it, then it's going to rotate as expected. So let's click on move component, and we're going to select standard drag, and if you move the ring gear, you can see that the planetary and sun gear moves correctly. And then we can set up collision detection if you want to stop the motion of the component once collision has been detected. The final option is physical dynamics. So what physical dynamics is going to do is it's going to translate the forces that we are providing while rotating one of the gears to the other components. So this is very useful to make sure that your assembly is set up correctly even before you run the motion analysis. So in our case, everything looks fine. So let's just exit out of this tool, and we are ready to set up our simulation. All right. So let's click on motion study, and we're going to just expand everything, and we need to make sure that we select motion analysis. However, we don't see it right now. So what we need to do is we need to go to SolidWorks add-ins and then make sure that SolidWorks motion is selected. So now we can go back, select motion analysis, and our strategy is quite simple. We are going to rotate the sun gear, and this motion is going to be transferred to the planetary gear, and from planetary gear to the outer gear. So click on motor, and we are going to be selecting the sun gear. So we need to make sure that we select the respective axis. If axis is turned off, click on show temporary axis, and then we should be able to select that. Now we are going to rotate this at 10 RPM and click on OK. So the next thing that we need to do is set up contacts, because that's basically how gears work and how they transmit energy. So let us select this particular face, and then for material we are going to say that hey, we are going to be using steel because that's what we are assuming our materials to be, and then let's click on OK. Similarly, we need to set up another contact pair between the planetary gear and the outer gear. So let's select both of them, and we are going to apply the same material in this case as well. Click OK when you're done. So now our simulation is set up, and we are ready to run this. So let's just click on the calculate button, and you can see that the motion is calculated perfectly and the gears have started moving. With that, I would like to conclude this video, and I'll see you guys in the next video. Bye.